Okay, so the first thing I'm going to do is I'll draw a little square. Okay, and it says that the diagonal of this square, so I'll just pull through a diagonal, is 11.3. Okay, and doing this problem will make our notes go faster because we're going to talk about how to solve this, and then we'll do it a little bit faster when we get to our notes. So then it says, give me the perimeter. Well, in order to get the perimeter, I need to know what the side length is. Well, the thing about a square is whatever this side is the same thing. And I don't know either of those, but all of them would be the same, right? So I have a right triangle, and it happens to be an isosceles right triangle because this is a 45 degrees and 45 degrees. Okay, so if you take a square and you put in the diagonal cuts that 90 degrees in half and makes a 45, 45, 90 right triangle. So when I do the Pythagorean theorem, I'm just kind of looking at this part right here, I'm going to do x squared plus x squared equals 11.3 squared. And the question is, how do I solve that? So we're going to need to know that for today. Okay, so x squared plus x squared equals 11.3 squared. So we've got x squared plus x squared equals 11.3 squared. Okay, so the 11.3, I can type that into my calculator and get a number for that. So it's 127.69. That's my 11.3 squared. Now I'm going to play on your Algebra 1. What's x squared plus x squared? One x squared plus another 1x squared is? 2x squared. Okay, so here I've got 2x squareds. It's very common for people to want to say that it's x to the 4th. Okay, and you do that. That is something that you can do, but you do that when you multiply the x's instead of adding. When you add them, there's 1, so you put them together, there's 2 of the same thing. So 2x squared. Okay, now again, we're going to play on your Algebra 1. I have to get rid of this 2 in the front, and I have to get rid of the squared. Which one do you do first? Okay, when you're solving, you do the order of operations backwards. Okay, so parentheses, exponents, multiplication. So you do that backwards when you solve. So you do the multiplication piece first. You undo multiplication first. So I'm going to divide by 2 on both sides. Square rooting should almost always be one of the last things that you do. So we're going to take this number, divide by 2. And I get 63.845. And then we know that wonderful feature, second square root, second answer. Which is 7.99, which is approximately 8. So it says approximately, so you could probably round that to 8. Okay. But then on this problem, so that's what we need to know for today. We're going to do another problem just like this in just a minute. So that's what you need to know for today. But for this particular problem, it says what's the perimeter. So to find the actual perimeter, I'll take that times 4 because it's a square. And my perimeter here, so I'll times that by 4. My perimeter is 31.96. And either way, that is an approximate answer because I didn't write down every single number that my calculator said. And actually, the calculator at the very end will round it anyway. So that's why it says approximately, because you can't give an exact answer. Okay. Now, I'm going to turn the page back to that 45, 45, 90 from today. Okay, because we just wrote down that those were all 45, that triangle that we dealt with was a 45, 45, 90. So what is so special about a 45, 45, 90? Well, first of all, it's a right triangle, so we could use Pythagorean theorem. That part is obvious. But really what we want to pay attention to is the fact that it is isosceles, which means the 2 legs are going to be equal to each other, which is going to make your life a lot easier as we go through, because you're going to have to find 2 missing sides of the triangles that you see below, and if the 2 legs are the same, that one is going to be easy. Okay, so there's a rule for these kind of triangles, but I'm not going to tell it to you. I'm going to make you figure it out. Okay, so what we're going to do is I have an example down here. I'm going to pick a number. Let's say I pick the number 3. Okay, so this side of the triangle is 3. If that side is 3, then this side would be 3, right? So my question is, what's the hypotenuse? And then we're going to simplify that. So we already did that, had somebody do it in their head, so let's go here. 3 squared plus 3 squared equals x squared, right? Or c squared, whatever you want to write there. So 3 squared plus 3 squared, if you type that into your calculator, right, we said just type it in. So 3 squared plus 3 squared is 18. And then you need to square root that. Now, in order to see the pattern, though, you cannot give me a decimal. You have to simplify the radical. Otherwise, you won't see the pattern. So when you simplify this radical, the perfect square inside of 18 is 9 times 2. What's the square root of 9? 3. And then I still have a root 2. Okay? Okay, so that's one example. Okay, let's try it again. Let's pick another number, maybe a number that's not prime, like 10. Okay? So let's try again. So that side's 10, that side's 10. On your paper, up in the corner, take a guess at what you think the hypotenuse might be. And maybe you don't know. That's okay. Just take a guess. Based on what we saw over here, what do you think the hypotenuse might be? And then we're actually going to figure it out. Because when you see a pattern, sometimes you just ask the teacher, like, is this always going to be blank? Well, let's figure it out. Okay? So we have a guess up here. Now let's figure it out. So I've got 10 squared plus 10 squared equals, and then x squared or c squared, whatever you want to write down. What's 10 squared plus 10 squared? 200. When you square root 200, what's the perfect square inside of 200? 10, because 100's in there, right? So it's 100 times 2. So the square root of 100 is 10. Radical 2. Did you guess that? Yeah. Okay, so this time, let's not work it out, because we're going to do the same kind of problem like 10 times. So once you figure out a pattern, let's say this side is, I don't know, 18. Your job today is to find this side and this side. Right? What's x? 18. What's y? Don't touch your calculator. What's y?
2.
Add 18, radical 2. Ta-da! Wasn't that easy? Look at that. So this is 18, and this is 18, radical 2. So the rule, here's the rule. The rule is, whatever this side is, this leg, the other leg is the same. We got that part already before we even started. And the hypotenuse is that same number, so we put an x because it's that same number, multiplied by radical 2. Now, I said that very specifically because what if that number on the side isn't 18, and what if it's radical 6? Would it be radical 6, radical 2? No, you'd actually have to multiply it. So I put that multiplication symbol there on purpose because we're going to kind of kick up a notch when we go to the examples below. Okay? So we have type 1 and we have type 2. The difference between the two is on type 1, you're given a leg, and you're asked to find the other two sides. And in type 2, I gave you the hypotenuse. Okay, so we'll talk about the difference between the two. All right, so let's focus on type 1 here for a minute. Can you find x and y right now without me saying anything? Yeah? What's x? 8. What's y? 8 radical 2, right? Easy peasy. Okay, so what we do is we take the leg times radical 2 to get the hypotenuse. Okay? So whatever the leg is. So what if the leg isn't 8? What if it's radical 10? Well, what is, to get the hypotenuse, you take that radical 10, whatever that leg is, and you multiply that, this is why that multiplication symbol is important, times radical 2. Now, we spent 2 days on radical rules. Can you walk away from radical 10, radical 2? No, you're not done. What is radical 10 times radical 2? Radical 20. Because you multiply those. They're both underneath the radical, so I multiply them. Can you walk away from radical 20? No, because there is a 4. There's a perfect square of 4 inside of it. So I've got to keep going. So when you multiply and you happen to get a radical, you need to make sure to simplify. Any radical you get before you circle it to be your final answer. Okay, so not 4 radical 5. There's a 4 and a 5, but what does radical 4 become? 2. So our final answer here, because it's 4 and 5, that becomes 2 radical 5. Okay? And then x, we're not going to think too hard on x. X is just the exact same as the other leg, so it's radical 10. Okay? So the harder that it's going to get is just that there might be a radical there that you have to deal with. But it's still just multiplied by radical 2. So same thing here. We can just swing this one over. That's the same. It's just 3 radical 2. And then to get m, you're going to multiply that leg times radical 2. There's already a radical 2 there. I don't care. You still have to put times radical 2. You haven't done that yet. So you have to make sure that even though there's a radical there in the answer, you have to put another one. Because you actually have to change it. You have to do something to it. Okay. We talked about this for a couple of days too. A couple days ago. What is radical 2 times radical 2? It's just 2. It's just 2. So this right here is just going to be 2. And what do you do with the 3 in the front? You times it. Yeah. So I'll write that out over here just in case that jumped over your head and you weren't really sure what just happened. So we have a 3 here in the front, and then 2 times 2 is radical 4. But we've talked about anytime you take a radical times itself, right, it's just going to be that number. So 3 times 2, so you could have skipped over that middle step if you wanted. So our final answer for that hypotenuse is going to be 6. So that number 6. Okay. How are you doing so far? Halfway there. Okay. This is why we practiced all of that radical stuff at the beginning of the packet, just to make this a little bit easier, so we weren't trying to learn both the rule and the radicals at the same time. Okay. All right, I'm going to slide over here to the second type. Okay, so for type 2, in this case, we have the hypotenuse. Okay, so this is our x side, this is our x side. This side right here is your x radical 2 side. So if I write in like a little baby equation there, right, this is our x times radical 2. How are you going to solve to get just x? Because remember, x is what this is. This is our x side, so we're trying to find x. How do you get rid of a times radical 2? You divide. Okay, so over here I put that you take the leg times radical 2 to get the hypotenuse. So if you put that backwards, right, flip it around because we're doing the opposite here. You take the hypotenuse divided by 2 to get the leg. Okay, so to go backwards, instead of multiplying, we're just going to be dividing, which is why we spent a whole day on division rules of radicals. Okay, so we're going to divide this. In order to solve this little baby equation right here, we would divide by radical 2. And this is the easy one, so don't overthink this. What happens to a radical 2 divided by radical 2? They cancel out, right? So x is just 8. So my two sides are just 8. And you can kind of confirm that because I used the same numbers over here, right? 8, 8, and 8 radical 2. 8, 8, and 8 radical 2. Okay, so we're going to try it now with this radical 10. I moved the radical 10 so it's in a different place. So we're going to take this radical 10 and we're going to divide it by radical 2. What is radical 10 divided by radical 2? And when we were doing our radical rules, I made the problems a lot more complicated so that when we got to this, it seemed very easy. So don't overthink this. What is radical 10 divided by radical 2? Radical 5. So the two sides, both the same, are radical 5. Okay? You simplify if necessary. You don't have to simplify radical 5, so we get to just move on. Okay? Here's where it gets a little bit more complicated because you have this rationalizing the denominator piece that we were working on. Okay, so I'm going to write this out here. I'm going to use this as my workspace so that we have this all worked out. So here's what we're going to do. We're going to take 19 and we're going to divide it by radical 2. Okay, that's how you get to the side length. You divide by radical 2. Can you walk away from a radical in the bottom? No. So what do you do? How do you do that? This is where we take and we multiply the top and the bottom by radical 2. That's called rationalizing the denominator. We did all of that practice with that. Okay, so on the top, across the top is not difficult. Don't overthink it. 19 times radical 2 is just plain old 19 radical 2. And then this is where we practice this. What's radical 2 times radical 2? It's just plain old 2. Okay, so I have that one right there at the top, and I threw another triangle in there just to reiterate the fact that if you can simplify, you should simplify. So on this bottom one right here, I changed the 19 to a 10. So my hypotenuse is 10, and so to get the leg, I'm going to divide by radical 2. So you would still do that, multiply by radical 2 over radical 2, and your final answer would end up with an even number on the top this time. So I just put 2 on here to reiterate the fact that if this number 19 is odd and it can't be divided by 2, you're done. You get to be done. But if that number happens to be even and it can be divided by 2, you should go that one more step to divide it. So the one on the top here, this 19 radical 2 over 2, that one is done. This one down here, we should reduce that to be 5 radical 2, and then we get to be done.